This is problem number 3, in which Andre is in charge of cooking broccoli and zucchini for a large group. Now he has two constraints. One is that he has to spend $17. He has $17. He has to spend all of that money to buy broccoli and zucchini. The zucchini costs $1.50 per pound, and the broccoli costs $2 per pound. And the other constraint is that he has to purchase 10 pounds. He can carry 10 pounds. He has to purchase 10 pounds. And so what combination of broccoli and zucchini at the same time costs $17 and weighs 10 pounds? And so if you look at these lines, one line is for 10 pounds and the other line is for $17. And the 10-pound line is the black graph. And one way to figure that out is just to pick a point and see if the zucchini and the broccoli both add up to 10 pounds. So this is 4 pounds of zucchini, 6 pounds of broccoli. So those two vegetables add up to 10 pounds. And notice that the slope of this black line is a -1. As you trade 1 pound of zucchini, if you want to stay on this line, you have to add, as you add 1 pound of zucchini, to stay on that black graph, you have to subtract 1 pound of broccoli. So that is a slope of -1. And we know that the broccoli plus the zucchini equals 10. So the pounds of zucchini plus the pounds of broccoli equal 10 pounds. So if you rewrite this equation in the slope-intercept form, you're going to get a slope of -1. That's a negative x or -1x right there. And so if you add a pound of zucchini, 1 times -1 is -1, plus 10 is 9. So as you add a pound of zucchini, you're going to subtract a pound of broccoli. So notice that the broccoli starts at 10 pounds. If all of the vegetables are just broccoli, that's at 10 pounds. And as you add a pound of zucchini each time, you take away a pound of broccoli. And the blue graph is the graph for $17. And so in this case, the cost of the zucchini, which is $1.50 for each pound of zucchini, plus the cost of broccoli, which is $2 for each pound of broccoli, equals $17. So if you rearrange this equation into the slope-intercept form, you're going to end up with this -1.5x moves over here. You add the additive inverse of 1.5x, makes a -1.5x right here. And if you divide through by 2 or multiply through by the multiplicative inverse of 1/2, then y is equal to -3/4 x plus 8.5 pounds. And so if you have all broccoli, so if you don't have any zucchini, so if this is 0, you're going to have 8.5 pounds of broccoli, which costs $17. So this starts way up here at the y-intercept, the y-axis, at 8.5 pounds of broccoli, which costs $17. Now each time you trade a pound of zucchini, so add a pound of zucchini, you have to subtract 3/4 of a pound of broccoli, because 1 pound of zucchini costs $1.50, and 3/4 of a pound of broccoli costs that same $1.50. So remember that the broccoli is $2 per pound, so 3/4 of a pound is going to cost $1.50. So it's 50 cents plus 50 cents plus 50 cents. That's 3/4. 1/4, 2/4, 3/4, and then 4/4 would be $2. But you want to keep it on this line for $17. And so notice for each exchange of a pound of broccoli for a pound of zucchini, if you look at the money line, the $17 line, that is 1/4 less. So there's 1/4 pound of broccoli gap that forms. That's 50 cents or 1/4 of a pound. 1/4 of a pound of broccoli costs 50 cents. Do that trade again, 1 pound, 3/4 of a pound, or 1 pound of zucchini, subtract 1 pound of zucchini, add 1 pound of broccoli. So that gap now is a half a pound. So it's 1/4, another 1/4, which is 1/2, another 1/4, which is 3/4, and that keeps increasing by 1/4 of a pound or 50 cents each time you trade 1 pound of zucchini for 1 pound of broccoli. So here's the calculation for the $17. So you can just choose this point right here and calculate the cost, which has to be $17. 4 times $1.50. 4 times 15 is 6, or 4 times 1.5 is $6. And $2 times 5.5 pounds. This is 5.5 right here. Now notice that every grid line is a half a pound for the broccoli. So this is 5.5 pounds. 2 times 5.5 pounds is 11 plus 6. That equals a total of $17. And so the number of pounds is the 4 pounds plus 5.5 pounds is 9.5 pounds. That's less than 10 pounds. So this combination is not equal to 10 pounds. That's this combination right here. The 6 pounds of zucchini and the 4 pounds of broccoli. But this combination is less than 10 pounds. It's 9.5 pounds because this line is less than the 10-pound line. And this combination is also more than $17. This 10 pounds up here is more than $17 because it's above this $17 line. So it turns out that that combination is $18. 4 times 1.5 pounds, we just did that calculation. 4 times 3/2. The 4 divided by 2 is 2. 2 times 3 is 6. Another way to calculate that. Plus $2 times 6 pounds is $12. Add those two together, that's $18. So the amount of money is more than $17, and the number of pounds for the $17 line is less than 10 pounds. So this is less than 10 pounds. This is more than $17. There are 3 problems related to the graph. One is, what's the combination of vegetables that weighs 10 pounds but does not cost $17? Second question is, what is the combination of vegetables that cost $17 but does not weigh 10 pounds? And the last question is actually the answer to the problem is, what's the combination of vegetables that cost both $17 and weighs 10 pounds? Now I'm going to answer C here first, and then use that answer to compare to A and B above. And so actually the answer to C is 6 pounds of zucchini and 4 pounds of broccoli. Weighs 10 pounds. And I'll go through this calculation in a minute, but it costs $17. But if you look at the graph, that is the point at which the $17 line, so this is $17, $17, $17, and then this along this line continues along this line, $17, and the 10-pound line, so this is 10 pounds, 10 pounds, 10 pounds. Any point on this line weighs 10 pounds of vegetables. It's this point right here in which they are the same, both 10 pounds of vegetables and $17 in cost. So 6 pounds of zucchini is equal to 6 times $1.50. If I use the distributive property and split that $1.50 out, that's 6 times 1 is $6, and 6 times $0.50, or 6 times 50 cents, is $3. So 6 plus 3 gives you $9 for the zucchini. And the broccoli is $2 per pound times 4 pounds. So that's a simple calculation of 2 times 4, or 4 times 2 is $8. Add the dollars together and it equals $17. Now how does that compare to A, which is 10 pounds of vegetables and a cost other than $17? I'm just going to use this point right here. So this is 10 pounds. But it doesn't cost $17. It actually costs more than $17 because it's above this line. So that point is at 4 pounds of zucchini and 6 pounds of broccoli. Well, 4 pounds of zucchini is $1.50 per pound times 4. 4 times 15 is 60. And so 4 times 1 5/10 is 6. So this is $6 for that 4 pounds, and 6 pounds of broccoli, $2 for each pound times 6 pounds gives you $12. Add these two together, That equals $18. Now notice that this point right here is 10 pounds of vegetables and it costs $18. So it increases $1 in cost. Keeping the pounds the same, goes from $17 to $18. So I'm going to show you this in steps, going from this point here of 6 pounds zucchini, 4 pounds of broccoli, to 5 and 5, to 4 pounds of zucchini and 6 pounds of broccoli. I'm going to show you these in steps, and you're going to see that the cost increases by 50 cents each time I trade a pound, because that 50 cents right here is equal to 1/4 of a pound of broccoli. So to keep this at 10 pounds, the cost increases by 50 cents. And so this gap that forms here is 1/4 of a pound, 50 cents for 1/4 of a pound of broccoli. And that gap continues to increase. So another pound, that gap increases another 1/4 of a pound. So now this gap is a 1/2 a pound. So it's a 1/4 of a pound, another 1/4 of a pound, which is a 1/2 a pound. And each time that 1/4 of a pound is 50 cents more. So if I go from 6 pounds of zucchini and 4 pounds of broccoli, that costs $17. So now I'm going to trade. So I'm going to go to 5 pounds of zucchini, and I'm going to add a pound of broccoli to 5 pounds of broccoli. So I'm keeping this at 10 pounds, but notice what happens to the cost. So as I subtract a pound of zucchini, this goes down $1.50, from $9 to $7.50. But the cost of the broccoli increases by 50 cents. It goes from $8, it increases by $2. It goes from $8 to $10. But the total increase, the difference, is an increase of 50 cents. It goes from $17 to $17.50. Once again, this decreases by $1.50. The broccoli increases by $2. So that's a net increase of 50 cents. If I make that trade again, go from 5 pounds of zucchini to 4 pounds of zucchini, this is going to drop by $1.50. It's going to go from $7.50 to $6. But the cost of the broccoli is going to increase by $2. It's going to go from $10 to $12. So notice that the net increase for each pound is an increase of 50 cents. It goes from $17 to $17.50 to $18. So that's a net increase of 1/4 of a pound over the $17 line for each trade of 1 pound. So here's the 4 pounds and 6 pounds zucchini and broccoli, and that equals a total of $18. So every time you trade, it's an increase of 1/4 of a pound over the $17 line. So this is an increase of 1/4, an increase of another 1/4. And so you notice, we'll get into this more, but that's the difference in these slopes. So -1 and a -3/4, the difference is a -1/4. So if you're going down this way, it's going to close this gap by 1/4 of a pound each time. That's the difference of these two slopes. Slope of this blue line is a -3/4. The slope of the pound line, this black graph, is a -1. All right, so let's look at the combination of $17 but does not weigh 10 pounds. So we're going to keep this at $17. So again, I'm just going to pick this point right here, which is on this blue graph. It costs $17, but it has to weigh less than 10 pounds. So 4 pounds of zucchini costs $6. We've already done that calculation. And 5.5 pounds of broccoli times $2 per pound cost $11. So that cost is $17, but the weight is less than 10 pounds. It's 9.5 pounds. So let's do the same thing. Let's step through this 1 pound at a time and see what happens. So we're going to keep the cost at $17. So 6 pounds of zucchini, 4 pounds of broccoli. So that costs $17. That's the original, that's where the lines intersect. That's the original calculation. So now we're going to trade a pound of zucchini. So we're going to drop this from 6 pounds to 5 pounds. So that's $1.50 less, but we have to add $1.50 for the broccoli. So we have to increase the amount of broccoli by 3/4 of a pound, because 3/4 of a pound is equal to $1.50. So we have to add 3/4 of a pound of broccoli to keep that graph on the $17 line. So this now costs $17 still. So it's 5 times 1.5 is $7.50. So that's a decrease of $1.50. But 4 3/4 times 2 is equal to $9.50. So it's an increase of $1.50 over the $8. Add them together, it's still equal to $17. And go to this last one, the point that we used. So we're going to drop the zucchini by 1 pound. That's a decrease of $1.50. So that means we have to increase the broccoli by $1.50, which is 3/4 of a pound. So you have to go from 4 3/4 pounds to 5.5 pounds. You have to increase that by 3/4 of a pound. That equals $11. And so the total cost is $17. But notice that the weight, the pounds, is dropping by 1/4 of a pound each trade of 1 pound of zucchini for 3/4 of a pound of broccoli. So it goes from 10 pounds to 9 3/4 pounds to 9.5 pounds. So on the graph, that's increasing this gap by 1/4 of a pound each time. Increasing this gap by 1/4 of a pound. It's 10 pounds to 9 3/4 pounds. So that's a gap of 1/4 of a pound. And 9 3/4 pounds to 9.5 pounds, that's a gap of another 1/4 of a pound. So the total for 2 pounds is a gap of 1/2 pound. And here it is all together. So this is an increase of 50 cents, an increase of 50 cents. So that 50 cents is 1/4 of a pound. Decrease of 1/4 of a pound, decrease of 1/4 of a pound. So that gap is increasing by 1/4 of a pound each time, keeping the cost the same, $17, $17. And here the total weight is 10 pounds and the total cost is $17. Take a look at what happens if we subtract pounds of broccoli or we subtract pounds of zucchini. So I'm going to zoom in on this image in just a moment. I just want you to see where that image comes from after I zoom in on it. And it comes from this larger image, and I'm showing changes in a half a pound actually of broccoli. I'm keeping zucchini the same. So notice that each of these grid lines is a half a pound. So this is 6 pounds of broccoli, 5.5 pounds, 5 pounds, 4.5 pounds. And now I'm going to keep broccoli the same and add a pound of zucchini. So this is 4 pounds of zucchini, 5 pounds of zucchini, 6 pounds of zucchini, and I'm going to keep the zucchini the same and subtract a half a pound of broccoli. So this is going to end up at a total of 10 pounds, $17, and this is the answer to the problem. 6 pounds of broccoli, 4 pounds of zucchini. This is $9. This is $8, adds to $17. So let's zoom in on this and take a closer look. But before we do, notice the change as you move down each of these lines at the same time. So a trade of 1 pound of zucchini. So I'm going to add a pound of zucchini. I'm going to subtract a pound of broccoli to stay on this 10-pound line. And down here on the $17 line, I'm going to add a pound of zucchini, but I'm going to subtract 3/4 of a pound of broccoli because that's equal to $1.50. So I add a pound of zucchini, that's adding $1.50. I'm subtracting 3/4 of a pound of broccoli, so that's subtracting $1.50. And notice this difference right here is 1/4 of a pound. And if I make that trade again, 1 pound of zucchini, 1 pound of broccoli, or on the dollar line, $17 line, 1 pound of zucchini, 3/4 of a pound of broccoli again, $1.50 for $1.50. That change again is 1/4 of a pound. It's always 1/4 of a pound. that is the difference in the slopes. So this slope here is actually the absolute value of the slopes. So this slope here, the absolute value is 1x. This is the absolute value of 3/4 x. That difference is 1/4 x, or 1/4 of a pound of broccoli for every pound of zucchini. So if I go the other way, this is there's zero difference. This is 1/4 of a pound. So this is another 1/4 of a pound, or a total of 1/2 pound difference. If you go up to these two lines, this difference right here is 3/4. So this is 3/4, 2/4, 1/4, and 0. And then if you keep going, this now is 1/4 of a pound difference. So this is 1/4. This is a 1/2 a pound, or 2/4. This is 3/4 right here, 3/4. And if you keep going, 1 more pound of zucchini, this is 4/4. So we'll see this again. And actually, if we solve this problem algebraically, it shows up in the algebra. But I just want you to see that that change, the total change, when you make these trades, is 1/4 of a pound for each pound of zucchini, because these two lines differ in their slope by 1/4. This is a slope of 1, or -1 actually. This is a slope of a -3/4. That difference is actually a -1/4, or if you look at the absolute values, a +1/4. Okay, so let's zoom in. So here's the axis, the y-axis for broccoli, and notice once again each of these grid lines is a 1/2 a pound, and the axis for zucchini, the x-axis, each of these grid lines is 1 pound for zucchini. So I'm going to keep the zucchini the same, and I'm going to subtract a 1/2 a pound of broccoli. So we're starting at $18. We figured that out before. If I subtract a 1/2 a pound of broccoli, how much money is that? Well, it's $2 per pound, so it's $1 for every 1/2 pound. So this is a 1/2 pound less, and this is $1 less, $17. This is just to get you used to the movement along these lines. What's happening in the change of pounds and the change of dollars. So if I subtract another pound of broccoli, that is a 1/2 pound of broccoli. That is another $1. So this is going from 9.5 pounds to 9 pounds, and it's $1 less, $16. Do that change again. It's going from 9 pounds to 8.5 pounds, and these dollars change from $1 from $16 to $15. So now I'm going to keep the broccoli the same and add a pound of zucchini. If I add a pound of zucchini, that is 9.5 pounds, and it's $1.50. So this should go to $16.50. So 9.5 pounds and $16.50. Make that change again. So add a pound of zucchini. So now it's 10.5 pounds. So I'm adding a whole pound of zucchini, but the dollar amount, the value, is $1.50. So it's going from $16.50 to $18. And now we're going to end up at the intersection, which again is 10 pounds and $17. So if I keep the zucchini the same and I subtract a 1/2 pound of broccoli, this is going to end up at 10 pounds. And the dollar amount, a 1/2 pound of broccoli, costs $1. So this is going to end up at $17 right here. And so this point right here is the intersection. It's where the combination of broccoli and zucchini weighs 10 pounds, and the combination of broccoli and zucchini costs $17. This is the only point at which that happens. So 6 and 4, $9, $8, a total of $17. Anywhere else, it's something other than 10 pounds or $17 or both. And here's that change of 1/4 of a pound. So if I start here, this difference is 1/2 of a pound. So add a pound of zucchini, subtract a pound of broccoli. So we're at this point here. Add a pound of zucchini in value, so that's $1.50. Subtract 3/4 of a pound of broccoli, so the value of that's $1.50. And so this change goes from a 1/2 pound difference to 1/4 of a pound. So it's a difference of 1/4 of a pound. Make that change again, goes to 0 difference, which is a change of 1/4 of a pound. Make that change again, 1 pound of zucchini, 1 pound of broccoli, or 1 pound of zucchini in money, so that's $1.50. 3/4 of a pound of broccoli is equal to that same $1.50. So now this is a 1/4 of a pound difference, and that was going to increase by 1/4 of a pound every time. So I just want you to see that 1 pound of change for the pounds or the dollar amount leads to a 1/4 pound difference in broccoli. In solving problems that have equations for two graphs, so two equations, two graphs, the focus is always on where is the intersection of those graphs, which is the solution to both equations. So the goal is to find the coordinates, and in this case, those coordinates are 6 pounds of zucchini and 4 pounds of broccoli that at the same time weigh 10 pounds and cost $17. So these coordinates are going to solve both equations, the equation for the $17 and the equation for 10 pounds. But what's happening at points other than this intersection? So usually it stops there. We've solved the problem. It's the intersection of the two graphs. The coordinates are. But what happens at these other points that are not on this intersection? So up here, the cost up here is $17, but it's less than 10 pounds. So why is this less than 10 pounds? And then it flips. Down here, it's still the cost of $17, but now the weight is greater than 10 pounds. And likewise, up here on this graph, this is a weight of 10 pounds, but now it's a cost of greater than $17. So as you move along this line right here, the cost is greater than $17, but the weight, the total weight, is 10 pounds. On the other hand, as you move past this intersection, on the other side, the cost is less than $17, but the total weight is still 10 pounds. So why does it flip like that? Why does it go from greater than $17, this is equal to $17, and this is less than $17? What's happening? So right here, this is a greater portion of the mix. It comes from the broccoli. So if you want the cost to still be $17, you don't have to add as much broccoli because broccoli is more expensive. So this is going to be less than 10 pounds, but still costs $17. Down here, a greater portion of the mix is zucchini. So if you want the cost to still be $17, you have to add more pounds because zucchini is not very expensive, so you need more of it to equal this $17. Here, the weight is going to be 10 pounds, and a greater portion of the mix on this portion of this part of the graph, it comes from broccoli. Well, broccoli costs more. So if you need a total weight to be 10 pounds, you have to add enough broccoli to equal 10 pounds, but broccoli is more expensive. So that's going to result in a cost of being greater than $17. And down here, a greater portion of this mix, an increasing portion of this mix is zucchini. Well, if you still want the total weight to be 10 pounds, you can add a lot of zucchini, but the cost is still going to be less than $17 because zucchini is not very expensive. So down here, 10 pounds, but less than $17. This is $17, but greater than 10 pounds. Because zucchini, again, is not very expensive. So if I need to get to $17, I have to add quite a bit of it. Up here, $17, but less than 10 pounds. Broccoli is expensive. So if I want to get to $17, I don't have to add very much. It's going to be less than 10 pounds. And here, 10 pounds, but greater than $17. I want to add enough broccoli to equal that 10 pounds, but broccoli is expensive. So it's going to be greater than the $17. When I look at these graphs for a system of equations, I like to think of a race. And so in this case, this black path is moving faster and it's catching up to the blue path. And when does it catch the blue path? It catches it right here. And you can also think of the blue path as moving slower and allowing the black path to catch. So when do they meet? They meet right here. So I'm going to reframe this as a race. So it's a movement along a horizontal axis. And so here it is. This is a series of red dots moving along a horizontal path, and a series of blue dots moving along a horizontal path. They're racing. When are the red dots and blue dots going to meet? And they meet right there, and now they start to separate again where the red dots move ahead of the blue dots. So let's look at this as a race, and I'm going to frame this in terms of each of these dots is 1 minute. And likewise down here, each of these dots is 1 minute. And the distance I'm going to just use as a mile. So in 1 minute, the red dots move 1 mile. So they're traveling at a mile a minute. That's 60 miles per hour if you're riding in a car. And the blue dots travel at 3/4 of a mile a minute. So that's traveling at 45 miles per hour. So 3/4 of a mile in 1 minute, 1 mile in 1 minute. So this is moving faster. 1 mile, 3/4 of a mile. Now, how much gain is there each minute of the red path, movement along the red path, catching movement along the blue path? So in 1 minute, how much closer are they for each minute? So they start out, the blue path starts out at 1.5 miles head start. The red path is going to start out at the starting line, which is 0. The blue path starts out 1.5 miles ahead. And so I'm going to rewrite that as that's 3/2 miles, or it's the same as 6/4 miles. And I want to use force because this movement right here is 3/4, and that's the slope, by the way. So this changes 1 mile every minute. That's a slope of 1 mile a minute. This changes 3/4 of a mile every minute, so this is a slope of 3/4, or 3/4 miles per 1 minute. So they start out, this path, the blue path, is 6/4 miles ahead, and after 1 minute, how much closer is this red dot to this blue dot? And then after another minute, how much closer is this red dot to this blue dot? Another minute, this red dot to this blue dot, and so on until they finally meet out here. So notice after 1 minute, the red dot looks like, oh, it's caught up. No, it's only 2/4 of a mile behind. But at the same time, this blue dot is moving ahead 3/4 of a mile. So what's the total distance that the blue dot is ahead of the red dot? So this moves ahead 1 mile here, but the blue dot moves ahead 3/4 of a mile. So there's a distance between them is now 5/4 of a mile. That's the difference in the slopes. So this is 1 mile a minute. This is 3/4 of a mile a minute. So think of this one as 4/4. What's 4/4 minus 3/4? Moves ahead 4/4. But then on the blue path, it moves ahead further by 3/4. So it's only a gain of that 1/4 of a mile. 4/4 minus 3/4. It's as if I've moved 4/4 ahead, but then I have to cancel out 3 of those 4s because the blue dot moves 3/4 of a mile ahead. So the gain is just 1/4 of a mile. So it goes from 6/4 difference to 5/4 difference. So let's look at that again. So the next one, this moves ahead 4/4 miles, or 1 mile. And so you think, oh, gee, it's only 1/4 of a mile behind, but this moves ahead 3/4. So it moves ahead 4/4, but then you have to subtract the 3/4 that this blue dot moves ahead. So 4/4 minus 3/4 is a 1/4 gain. So now instead of 5/4 of a distance between, you have 4/4 of a mile distance between, or 1 mile. Now it's 3/4. It's gained 1/4 of a mile. Now 2/4, it's gained 1/4 of a mile. Now it's 1/4, it's gained 1/4 of a mile. So why 1/4 of a gain? That's the difference between this 1 mile and this 3/4 of a mile. So 1 minus 3/4 equals 1/4. So every time it's gaining 1/4 of a mile. So finally it's caught up. So now if the blue path starts out 6/4 of a mile ahead, and it's gaining 1/4 of a mile each minute, then how many minutes is it going to take? Well, that's 6/4 divided by 1/4. It's a 1/4 gain each minute. You have 6/4 miles. So it's 6/4 divided by 1/4. How many fourths are in 6/4? Well, there's 6 of them. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then along the red path, it passes the blue path by now 1/4 of a mile. So now the blue path is 1/4 of a mile behind. It's going to get further and further behind by 1/4 of a mile every minute as it runs past each other. So what does this race look like for the zucchini and broccoli problem? So what I've done is I've taken the zucchini, the pound for pound line, so the 10-pound line, and placed that on a horizontal path. And I've taken the $17 line and placed that on a horizontal path. So now we're just looking at the change along the y-axis, but as if it is a race along a horizontal path. This is the same graph that I just used, the same image that I just used for the mile per minute or the 3/4 miles per minute. It's exactly the same. So if I go back and forth, you can see that those dots line up. All right, so for zucchini and broccoli along 10 pounds, it's a trade of 1 pound of zucchini for 1 pound of broccoli. So you add a pound of zucchini, you subtract a pound of broccoli, and you stay at 10 pounds. For the $17 line, you add a pound of zucchini, but you subtract 3/4 of a pound of broccoli. So there's a gain of 1/4 of a pound because zucchini doesn't cost as much. So to stay at $17, you have to add 1/4 of a pound more of zucchini. So in other words, broccoli costs $2 a pound. So $1.50 of broccoli is equal to 3/4 of a pound. So you take that 3/4 of a pound away, you add a pound of zucchini. That difference, the 1 minus 3/4, is an extra 1/4 pound of zucchini because zucchini doesn't cost as much. So you need more of it. You need 1/4 pound more of zucchini. So when does the $17 line catch up to the 10-pound line? So when does $17 equal 10 pounds? So if you go to the next trade, a pound for a pound of zucchini and broccoli along 10 pounds, this is going to decrease by 3/4 of a pound of broccoli. So this is a 3/4 of a pound decrease for broccoli, 3/4 of a pound decrease, 3/4 of a pound decrease. So you're taking 3/4 of a pound of broccoli away each time. We'll get to the zucchini in just a moment. So you subtract 3/4 of a pound, subtract 3/4 of a pound, subtract 3/4 of a pound, and subtract 3/4 of a pound. And here they're even. They're both at 10 pounds because the total is you're adding a pound of zucchini, so the difference is that 1/4 of a pound. So you're adding 1/4 of a pound each time. Subtract 3/4 of a pound, add a pound. That's the difference of the slopes. Slope here is a -1. The slope here is a -3/4. Taking 1 pound of broccoli away for adding a pound of zucchini, taking 3/4 of a pound of broccoli away for adding a pound of zucchini to keep it at $17. So that difference, and so the absolute value, so negative slopes, I'm going to look at the absolute value. So 1 minus 3/4 is a net gain of 1/4 of a pound. So 8.5 pounds to 8 3/4 pounds to 9 pounds. this is increasing, the total is increasing by 1/4 of a pound each time. So remember, the $17 line starts out at 8.5 pounds of broccoli. So there's 3.5 pounds, or I'm sorry, 3/2 pounds difference, 1.5 pounds, or 6/4. So this goes back to the last problem we just did for the miles per minute. So what's 6/4 divided by 1/4? So it's a gain of 1/4 of a pound each time. So how many pounds of zucchini am I going to have to trade to get to 10 pounds along this $17 line? So this is tough. You just have to keep looking at it and keep thinking about it. But it's going to be 6 pounds. So 6/4. So this is 6/4 of a pound ahead. That's 6/4 divided by 1/4 each time. So there's a gain of 1/4 of a pound each time. It's going to take 6 pounds, 6/4 divided by 1/4, or which equals 6. So 6 pounds of broccoli to get to 10 pounds total, to get to where they meet. You're closing this gap each time. The gap is 6/4 pounds, 1.5 pounds, 3/2 pounds. It's all the same. So 6/4 divided by 1/4, closing that gap each time. 6/4 divided by 1/4 is equal to 6. You're going to go out 6 pounds of zucchini. So this is adding 1/4 of a pound, adding 1/4 of a pound, adding 1/4 of a pound, and so on. So this is an increase of 1 pound and an increase of 3/4 pounds. I'm sorry, actually this stays the same weight of 10 pounds, but this increases by 1/4 of a pound because it stays the same cost as $17. So this is the same weight, 10 pounds. This is increasing by 1/4 of a pound. So that difference, that 1/4 of a pound increase, is the difference between the absolute values of these slopes. It's the positive value. So 1 minus 3/4. This row gains 1/4. Well, actually, take a look at it this way. This moves 1/4 of a pound closer to 10 pounds each time. So 1/4 of a pound closer. So this is a trade. This is staying at 10 pounds. This is moving 1/4 of a pound closer. Staying at 10 pounds, moving 1/4 of a pound closer. Staying at 10 pounds, moving 1/4 of a pound closer, because that's 1 minus 3/4. So it's moving 1/4 of a pound closer each time. 1/4 of a pound closer, 1/4 of a pound closer. So here it's caught up to the 10 pounds. So now both lines are at 10 pounds. This is $17, cost 10 pounds. That's the answer to the problem. It's where those two graphs intersect. If you went beyond it, this would be more than 10 pounds now. So it's 1/4 of a pound more than 10 pounds, but still costs $17. And this is still on the 10 pound line. As I've worked on these problems, I'm seeing a general pattern of how I approach the problems. And so I look at it as a race, as I mentioned before. And if this is a decreasing amount each time, so whatever it is, for each unit along the x-axis, this value is going down 1 unit, and this value is going down 1/2 a unit. So this is decreasing faster than this is decreasing. So eventually the red graph will catch the blue graph because it's decreasing faster, or you can think of the blue graph slowing down to allow the red graph to catch it, because the blue graph is moving slower for each unit along the x-axis. So first of all, look at the difference that these two starting points are apart. So they're apart by 3 units, 1, 2, 3. And then how much for each unit along the x-axis, how close do these two graphs move each time? Well, the first unit, you're going to chop off this amount. So this is that amount closer. So that's 1 unit. It's a -1, so it's moving 1 unit closer. But at the same time, you're going to add this amount down here. So this is a -3/4. So that's the difference between 1 unit. You're removing 1 unit, but you're adding back, I'm sorry, this is a negative 1/2. You're removing 1 unit, but you're adding back 1/2 of a unit. So what's the net amount that these two graphs are moving together? They're moving together 1/2 of a unit for each unit moved along the x-axis. So this is moving closer by 1 unit, but moving farther apart by 1/2 a unit. This is as if you're taking away $1 from somebody, but you're giving them $1/2 back. So their net loss is 1/2 of $1. So you're taking away 1 unit, but you're giving back a 1/2 of a unit. So the net close in this case, how close they move together, is 1/2 of a unit for each unit moved along the x-axis. Well, how many times does that take to meet down here? Well, they're 3 units apart. They're closing at 1/2 a unit for each unit along the x-axis. So what's 3 divided by that 1/2? Well, 3 divided by 1/2 is 6. So out here, they're going to meet 6 units along the x-axis out. And then you can figure out what the value is along the y-axis by using this 6 and either on the graph or using the equations to figure out that it's 1 unit on the y-axis. Now in this case, if you have two graphs where there's increasing amounts, so it's a positive slope, this red line is increasing faster than this blue line. So eventually the red line is going to catch the blue line. But how far do they start apart? How far apart are they when they begin? Well, they are 1, 2, 3, 4 units apart. And so how much gain is there, or how close do they move for each unit along the x-axis? Well, so here's this 1 unit along the x-axis. How much less is this distance than this distance, or this amount, compared to this amount? Well, it gains 1 unit, so it's 1 unit closer. So it's like chopping off this piece, but then you're adding this 1/2 a unit up here. So what's the net gain, or what's the net what's the net gain and how much closer these two graphs are moving? It's 1 unit here minus this 1/2 a unit. So again, it's like giving somebody $1 but taking 1/2 a dollar away. So the net gain is 1/2 of a unit. And how many times can you do that? It's 1, 2, 3, 4. 4 times, and it's a net gain of 1/2 of a unit each time. So it's 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. So 4 divided by 1/2, so it's 1/2 a unit closer each time. 4 divided by 1/2 is 8. So these two graphs are going to intersect or meet out here 8 units along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. And the value along the y-axis, you can use the x-coordinate to figure out what the y-coordinate is, either along the graph or using the equation for either one of these graphs. Now, what if there's a movement towards each other? So the red graph is moving towards the blue graph. So when are they going to meet? So start out by figuring out how far they are apart. In this case, they're 1, 2, 3, 4, 5, 6 units apart. And how quickly are they coming together for each unit along the x-axis? Well, this is moving together. This is moving forward or closer by 1/2 a unit. And up here, this is moving closer by 1 unit. So it's the sum of those two. This is 1.5 units closer each time. Well, they're 1, 2, 3, 4, 5, 6 units apart, but the sum of the slopes, this is 1 plus 1/2 is 1.5, or 3/2. What's 6 divided by 3/2? That's 2/3 of 6. 6 divided by 3/2 is 2/3 times 6, or 6 divided by 3 is 2. 2 times 2 is 4. So you're going to go out here 4 units, because you're gaining 1.5 units each time. So this is 1.5 units, 1.5 units, 1.5 units, 1.5 units. That happens 4 times. 1, 2, 3, 4. So they meet out here at 4 units along the x-axis. And to figure out the value along the y-axis, just use this coordinate and use the graph, or use either one of these 2 equations and this value of x, and you can figure out the value of y. So this is a general method or a general model that I'm using to look at every single one of these problems. The distance that they are apart and how quickly are they moving together. And you divide the distance that they are apart by how quickly they're moving together. Has to do with the slope. To compare the graphs to the equations, there are actually 4 calculations that show up in the graphs as you solve the equation. So I'm going to show you the equation in a moment. But what I did is I extended both of these graphs out to the y-axis and out to the x-axis down here. And so let's start with the y-intercepts when it's all broccoli. So if you have 10 pounds of broccoli, that costs $20. So this value right here is $20, and the weight is 10 pounds. So it's all broccoli. And let's look at that slope for just a second. If you trade 1 pound of broccoli for 1 pound of zucchini, you stay on this 10-pound line. Now the cost is going to change. The cost is going to move from $20 and it's going to move towards $17 as you approach this point where the 2 graphs intersect. So this is 10 pounds and this is 10 pounds with a slope of -1. Trade 1 pound of broccoli for 1 pound of zucchini. But then when you look at the $17 graph, that is 8.5 pounds because broccoli is $2 per pound. So $17 divided by 2 is equal to 8.5 pounds. So 2 times 8.5 is $17. So that starts out here, and now you trade 3/4 of a pound of broccoli for 1 pound of zucchini, because 1 pound of zucchini costs $1.50, and 3/4 of a pound of broccoli also costs $1.50. So you want to stay on this same value of $17. So this is 3/4 of a pound. So this is 1/4 of a pound more. You get 1 pound of zucchini because zucchini costs less, so you need more of it to make up that $17. So you need 1/4 of a pound more. So here's a little picture down here of broccoli costs $2 per pound, costs $1 for half a pound, and it costs $1.50 for 3/4 of a pound right here. And the 2 equations, the equation for the 10 pounds, that one's pretty easy because they just add together to equal 10. So y plus x equals 10. And if we write this in the slope-intercept form, y equals a -1x plus 10. And so the y-intercept up here is 10, and the slope is -1. -1 for every +1 pound of zucchini. And the equation for $17 is $17 is equal to the cost of $1.50 for each pound of zucchini, that's 3/2, plus $2 for each pound of broccoli, so that's 2 times each pound of broccoli. And so I'm just going to rearrange this and write this in the slope-intercept form. So I'm moving this portion of the equation to this side to get y over here, and moving the $17 to this side. Add a -3/2 x to both sides, so this becomes a -3/2 x, and then multiply through by 1/2. So think about this just for a second. 1/2 of 3/2 equals 3/4. So if you think of 3/2 as 3 $. Each $0.50 is equal to 2/4, so that would be 6/4. And what's 1/2 of 6? Well, 1/2 of 6 is 3, so 1/2 of 6/4 is 3/4. Plus the 8.5 pounds for $17. So here's the y-intercept here of 8.5 and a slope of a -3/4. So for every 1 pound of zucchini, you subtract 3/4 of a pound of broccoli because once again, that's an equal cost. It's both $1.50. So if you change these coordinates to money, this 1 pound is equal to $1.50 for zucchini, and 7 3/4 pounds is actually equal to $15.50 for broccoli. So it's $17 minus that $1.50. Add those two together, that equals $17. So when you solve these equations, to find this point, where do these graphs intersect? You're going to do some algebra, and that's the basis of the next few lessons. But I just want to show you that the calculations to solve the equation shows up in these graphs. You'll be able to see it in the graphs. So this is the point right here where both graphs have the same coordinates, the same x value and the same y value. So if y is equal for both of these graphs, up here, that means that this y value equals this y value when these graphs meet. So if y equals y, that means that this expression right here is equal to this expression right here. So then you can set those two expressions equal to each other and solve for the value of x. That's going to give you this coordinate right here, and then you're going to use that to figure out what the y coordinate is. So we're going to do that in the next few lessons, but I just want to show you that as you go through those steps are going to show up in these graphs. So the first one is if I set y, this expression, equal to this expression, so y equals y, so a negative 1x plus 10 equals a negative 3/4 x plus 8.5. The first thing you're going to do is find the difference between 10 and 8.5. You're actually going to subtract 8.5 from both sides, or add a negative 8.5 to each side. So you're going to end up with 10 minus 8.5. Well, where does that show up on the graph? That's this difference right here. This is that 10 pounds minus this 8.5 pounds. So this length, or this amount right here, this value, is the difference between 10 and 8.5. It is 3/2. 1.5 or 3/2. So 10 minus 8.5 is 3/2. Then the next thing you're going to do when you solve equations is you're going to subtract find the difference of the slopes. So this has a slope of -1. This has a slope of a negative 3/4 right here. And so that difference, remember, that's that 1/4 pound of zucchini extra. So the difference in the slopes is, and in this case, I'm going to use the positive values of each. So this is going to be 1 minus 3/4. So 1 minus 3/4, and I'll show you why that you can use the positive value in the next few lessons. But for right now, that difference is a slope of 1 minus a slope of 3/4. They're actually negative in the graphs. I'm using the positive values right now. That difference is 1/4. That's that 1/4 pound of zucchini extra that you have to add, because zucchini doesn't cost as much. So to keep on the $17 line, you have an extra 1/4 pound of zucchini. That's the difference. And that shows up right here. So if you go to the next length here, remember this length goes ahead by 1 unit. That's the same as 4/4. But at the same time, on this graph, this goes ahead by 3/4. So you remember it catches up to the blue graph by 4/4, but then this moves ahead by 3/4. So there's a net gain, a net increase in weight as you move along the $17 line of 1/4 pound for every pound of zucchini that's added, because you have to add an extra 1/4 pound of zucchini to stay on this $17 line. So 1 minus 3/4 is that extra 1/4. This is the difference in the slopes. So I'm going to add 1/4 pound more. I'm going to get 1/4 pound closer. So this is going to go from 6/4. This length right here is 3/2 or 6/4 to 5/4. So if you remember from the race example, this moves ahead 4/4, so now it's just 2/4 behind. But unfortunately, at the same time, on this graph, this moves ahead 3/4. So it's that 2/4 plus 3/4 is a total of 5/4. So it's a net gain of 5/4. And the difference is 1/4. So how many times can you do that? Well, that's 6/4 divided by a net gain of 1/4. So how many times you do that is when these two graphs are going to meet. So that's 6/4 divided by 1/4. It's the same as 6/4 is the same as 3/2. 3/2 divided by 1/4 is the same as 3/2 times 4. Remember, you're going to multiply it by the multiplicative inverse. 4 times 3 is 12. 12 divided by 2 is 6. So the number of pounds of zucchini is going to be 6 pounds when they meet, because you can move 1/4 of a pound closer for each pound of zucchini, and you have 6/4 to do that, or 3/2, same thing. And then the last calculation is you're going to use that 6 pounds of zucchini to figure out that, and you can use either equation to figure out that at the same time you're going to have 4 pounds of broccoli. So 4 calculations. How far are these points apart in the beginning? How much do they move together for each unit of x? So that's the 1/4 unit they move together. How many times can you do that? That's this length right here divided by that 1/4. And then, so that answer is 6. And so then you're going to use that 6 pounds of zucchini to figure out that you have 4 pounds of broccoli that goes along with it. It's going to take a while.